Good evening. Welcome to
Family Math number 12.
Family Math number 12. Today we're going to talk about a really fun story about a famous mathematician named Carl Friedrich Gauss. Gauss is known as one of the most smartest, most amazing, most incredible mathematicians of all time. But when he was a little kid, sometimes he misbehaved. And the story goes that like when he was 6 or 7, he wasn't behaving, and his teacher sent him into the corner and said, "You cannot come back until you tell me what 1 plus 2 plus 3 plus 4 plus all the way up to 99 plus 100 is." And Gauss, who was just a kid, but would turn out to be one of the smartest mathematicians of all time, said to his teacher, "But that's just 5,050. And his teacher said, "What?" And so let's see how Gauss could add that up so fast. What Gauss supposedly said is if you let this equal x, then x is also the same if you write it backwards, right? So you get...
Is this called the Gauss conjecture?
No. 100 plus 99 plus 98 plus 97 plus 2 plus 1. So this is just writing it forwards. Watch out for the shadow, sweetie. This is writing it forwards. 1 plus 2 plus 3 plus 4 plus ... plus 99 plus 100. This is writing it backwards. 100 plus 99 plus 98 plus 97 ... plus 2 plus 1. Now those are the same. Why are they the same? Why is it the same if you write it forwards and backwards?
Because of the commutative property.
Because addition is commutative. Addition, if you do a plus b, that's the same as b plus a. And then what Gauss said is that, well, if I just add these together, I get 2x, twice what I'm supposed to get. So I'm going to have to, if I have 2 times something, what do I have to remember to do at the end?
Divided by 2.
2 times 1 plus 100 is 101. 2 plus 99 is
101.
101.
A bunch of 101s.
3 plus 98 is
101.
4 plus 97 is
101.
99 plus 2 is
101.
101, and 100 plus 1 is
101.
So we have a bunch of 101s. Oops, I bumped the camera. Sorry about that. We have a bunch of 101s, and in fact, how many 101s do we have? Can anyone tell me?
100.
Why do we know? How do you know we have 100?
Because there's 100 numbers.
Because there's 100 numbers. So this is the same. 2x equals 100 times 101, and it's very easy to multiply by 100. What do you do?
Add 2 zeros.
So I get 10100, which is just 10,100. And now I have to divide by 2.
Which is 5,050.
X equals 5,050 when you divide that by 2.
How would you add that up so fast? How do you do that in 1 second?
Well, he knew the trick.
Oh.
He knew the trick. So what if we were going to do... Not that you guys would ever be bad, right? You're always good. Har har. You're always har har. But what if I sent you into the corner and said, I want you to add up the numbers from 1 to 20? That's 20. What could you do?
I think I figured it out.
What could you do?
Well, you could do it backwards.
First you write it backwards. Next you
add it.
You add it up. You say 2x equals 21 plus 21 plus 21 plus 21 plus 21. And how many 21s do I have?
20.
20. So 2x equals 21 times 20. Now I have to divide this whole thing by 2. Well, I'm going to divide by 2 first because 20 divided by 2 is...
It's going to be 40.
20 divided by 2 is...
20 divided by 2
is...
10.
10, right? So x equals 21 times 10. And we know how to multiply by 10. 21 times 10 is?
210.
210. So you could come back from the corner then. But the amazing thing is you can do this for any number, as long as you start at 1. So I could ask you how to add up 1 plus 2 plus 3 plus 4 plus I don't know, 1,999 plus 2,000. Whoa. Whoa. Whoa, whoa, whoa. So when you added them, when you wrote them backwards, you would get 2,000 plus 1999 plus 2 plus 1. So you'd get a bunch of 2001s.
It's 2,000 times 2001, which is and
so I would get 2x, like we had before. 2x equals 2,000 times 2001. Now the easy thing is to divide by 2 first, right? What number am I going to divide by 2?
The 2,000, so we get...
So I get x equals 1,000 times 2001, which is what?
Which is 2001.
2001,000. In other words, 2,001,000.
Whoa!
Whoa, can you believe that?
That's a huge number. Whoa.
So the question is, so this is a neat trick, but why does it work? And I want to show you with a much easier example than adding up all the numbers to 2,000. But can you believe how easy that is to add up all the numbers to 2,000?
Yeah.
If I would have just said to you, add up all the numbers to 2,000, what would you have said?
It's just 2,001,000.
That's what you would have said? What would you probably have actually said?
If you didn't know this trick.
If you didn't know this trick, you'd probably say,
I don't know.
Rah, rah. So we're going to take a much easier example, and I'm going to show you a neat geometry way to think about this, and we're just going to add up 1, 2, 3, 4, 5, 6. Okay? Whoa, 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 wait a second. 1 plus 2 plus 3 plus 4 plus 5 plus 6. That's what we're going to figure out. Okay? Okay, now this isn't too hard to do. You could just add this up yourself, right? Because 1 plus 2 is
3.
And then plus 3 is
6.
Wait. Plus 6 plus 4 is
10.
10 plus 5 is
15.
15 plus 6 is
21.
Okay, so hopefully this isn't too hard. We can see this is 21, but instead we're going to get out our friendly little Duplo blocks. And we're going to make 1, 2, 3, 4, 5, and 6. So here's what we're trying to add up. Can everybody see this?
Now we can parallel this.
Well, hold on one second. Hold on one second. Is this actually on camera? There we go. Okay. Now, over on this side with blue blocks, instead I'm going to make a 6 plus 5 plus 4 plus 3 plus 2 plus 1. Remember how first we write them forwards, then we write them backwards?
Yep.
So there's 6 plus 5 plus 4 plus 3 plus 2, you know what last one? Plus 1. Okay, so this is pretty neat. Now, imagine, now we could do this up to 100 if we wanted, we just don't have that many Duplo blocks.
And we don't have enough room.
And we don't have enough room. And we don't have enough time. So first we wrote them forward. 1, 2, 3, 4, 5, 6. Then we wrote them backwards. And now what we're going to do is we're going to add them together. And what do you think it means geometrically to add these together? What should we do?
Mush them.
Mush them together? Okay, let's try to do that. Didn't quite fit. I guess the blue blocks aren't quite the same as the yellow blocks. Maybe I should have tested this ahead of time. Okay.
Ooh, look at this.
Now, what kind of shape did they make when we mushed them together?
A square. Looks.
Is it a square? Are you sure?
Well, this sort of looks like a picture, like stairs in a blue sky.
It does kind of look like stairs in the blue sky. But is this a square? Lean back a little. Is this a square or is it a slightly different shape?
It's a 6 by 7.
It's a 6 by 7. And what is it? If it's 6 this way and 7 this way, what shape is that?
It's a rectangle.
It's a rectangle. Very good. And how do you find the area of a rectangle? Do you know?
I know. L times width. L times
Length
W.
times width. So 6 times 7, length times width, is 42. And so that tells us there are 42 blocks here,
But
all in all.
We're only trying to figure out the stairs.
But we were only trying to figure out how many yellow blocks there were.
So
But what do we know that's really special about this picture, about the yellow blocks and the blue
They're the
blocks?
same.
Why are they the same?
Because you just wrote them forwards and backwards.
Okay, here's the 1. Where's the 1 in the blue blocks? Okay, now your turn. Here's the 2. Where's the 2 in the blue blocks?
The 2 in the blue box?
Where's the 2 in the blue blocks? If they're the same, we should be able to match them up. The 1's here, and 1's here. 2's there, 2's there. 3's here, 3's there. 4, 5, all the way through. So this is pretty neat. So we have 42 blocks in all, and the yellow blocks have the same number of blocks as the blue blocks. So how many yellow blocks are there?
21.
21. And you know what? You could do this for any number. If you wanted to add up 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, you could make it all with 10 blocks, write them backwards with 10 blocks, mush them together, and you'd get a rectangle that was 10 tall and 11 wide.
It still looks like the stairs.
It would look like the stairs in the sky, as long as you use yellow and blue.
Well,
and that's how we found 21 blocks. So isn't this pretty neat? It turns out to be really, really easy to just add up what?
All the integers.
When you start at 1 and go up by 1, and just go up to, like, 20 or 6 or 100, or we even did 2,000. Do you remember what all the integers from 1 to 2,000 add up to be?
It was like 2,001,000.
2,001,000. Very good. All right, high five, everybody.
Oh, yeah.
Good job on family math tonight.